The 2022 APCS free response questions are out, and we're going to take a crack at explaining them. Let's get started. Two things I want to point out before we get started so you don't get confused. The code is copied straight from the code snippets that are in the FRQs, but they are altered slightly. So this isn't in there. They have helper members and functions in this particular thing. And that's because we want to have our runner classes. Each of these questions has a runner class that runs the code that we're going to go through with sample data that they provide. So in order to get these games to run, we have to kind of fill in some of the gaps. So with that, let's get started with question 1. We're going to highlight things that we need to pay attention to as we skim through these questions. This first question is talking about a video game. In the game, a player attempts to complete 3 levels. A level is represented by the level class. Okay, so they give us this level class where a goal is reached and we get points. Okay, so one's a goal and one's points. Play of the game is represented by the game class, and we will write 2 methods of the game class. So our A and B is going to be 2 methods. We have 3 level variables. We have a constructor we don't care about. There's this thing called isBonus, which will return true if a game is a bonus game. So somehow we're going to need to deal with that. Simulate the play of the game. Okay, so running this class will simulate playing the game. And then we have part A and part B, which is get, score, and play many times. Okay, so given that, let's take a look at what they want us to do for A. So we want to write the get score method, which returns the score of the most recently played game. Each game consists of 3 levels. Okay, so we're going to run all 3 of these levels in order to play a game. The score for the game is computed using the following helper methods. Okay, so we're using the isBonus to determine whether the game is a bonus game or not, so it returns true or false. The goal reached, okay, so the goal reached of the level class will tell us if that particular level has been reached or not. And then the get points, which will tell us how many points that particular level has. All right, so we're going to be using probably all 3 of these methods. The score for the game is computed according to the following rules. Level 1 points are earned only if the level 1 goal is reached. So for that level 1 variable, we're going to be using, I'm guessing, the goal reach function to determine if it's reached. Level 2 points are earned if level 1 and level 2. So we're going to use the goal reach for both level 1 and level 2 to determine whether we count level 2's points, and then level 3 if all 3. The score is the sum of the points for level 1, 2, and 3. And then lastly, the game is a bonus game. We're going to need to multiply it times 3. Okay, so let's move over to the code, and we're going to implement get score. So all this will wipe out. Let's create a variable, and sum equals 0. So we'll start off with 0 points, and ultimately we're going to return sum. All right, we've got that. We want to count the points if level 1's goal is reached. So we're going to do it if level 1 goal reached. Okay, if we have that goal reached, we want to sum plus equals level 1 dot get points. All right, so we've done that. Now we want to add level 2's points if level 1 and level 2 is reached. So I could put another if statement right after this one, but I'm not going to. I could say if level 1 and level 2. We probably don't need to. We can be a little crafty and just put it in here. We're not going to reach. If level 1's not reached, then we're not going to hit this point where we go level 2. All right, so we embedded it in 1. We're only going to add level 2's points if level 1 and level 2 is reached, and we'll do the same for level 3. If level 3 is goals reached, we'll add level 3. All right, that was pretty quick. All right, lastly, they do point one last thing out. If the game is a bonus game, we want to triple the score. So we'll need to multiply it by 3. So we'll put a little if statement here. If is bonus, remember that is bonus function. That is bonus function right here. Then we'll want to say return sum times 3. All right, we finished part 1. That looks great. Let's try play many times. All right, we can take a look at the sample data, and we'll run through this sample data in the runner. But play many times. Write the play many times method, which simulates the number of games, which simulates the play of the num games and returns the highest game score earned. For example, if 4 plays are called play many times 4, so if we put in 4 into play many times, the score can be one of these 4, and the method should return 90 because it just keeps track of the highest score. All right. Play is simulated by the helper method play. So if we look back at the score, so we're going to simulate. So I guess when we pass in the values, we're going to run play that many times, which will simulate the play. And note that if play is only called one time, followed by multiple consecutive calls to get score, each call to get score will return the score. So we're going to loop through however many times that we put in. We'll call play, and then we'll call get score, and we'll track get score to make sure only the highest is tracked. Let's take a look at the code. Let's create a variable, int max equals 0. We're going to assume that there's not negative scores, and we'll return max when that's done. We're going to loop through and run play and get the score and compare the score. So simple loop for int I equals 0, I less than num, I plus plus. And what are we going to want to do each time we run through each play? We're going to want to simulate play, so let's call play. All right. Now we want to get a variable and hold the score. Int score equals get score from the previous one. So this is the previous one. Now that we're holding score, we're going to want to compare it with the previous. So if score is greater than the max, we're going to want to store max equals score. All right, that should do it. Let's take a look at the sample data. So the first sample data we have is level 1 is true and 200 points. 2 is true and 100, 3 true 500, and last one, the bonus, is true. So 2, we count all 3 because all 3 are true. We count them, we add them all up, and because this is true, we multiply it by 3, and it should result in 2400. We notice that the first 2 are true, and the next one's false. We just add up 200 and 100, and there is no bonus, so we don't multiply it, and that should be 300 points. The first is true, but the second is false, so we don't add anything after that. We should just add 200, and this is a bonus, so we should multiply it times 3, which results in 600. And lastly, the first one is false, so everything should equal 0 because we don't get points for anything. Even though the level 2 and level 3 were passed, level 1 was not, so we don't get credit for anything. Let's take a look at the code. So we've simulated that here in the runner, and what we should see, I should clear that out. Here we've simulated in the runner. What we should see if I run this is 2,400, 300, 600, and 0. So that matches our data on the sheet. Let's take a look at the second play many times method. What we want is play many times to have different values and only keep the last score that's the highest. So how do we do that? Well, I put additional code in the game class called simulate play, which will take those 4 sample games that had 2,400, 600, 300, and 0, and randomly simulates that as a play. So when I run this, let's run it one time. It should keep track of the highest score. So we see when we play for 2 times the first time, both scores were 0, so the max score is 0. Now we play it 7 times, the max score happens to be 2,400, so we keep 2,400. Let's run it again just to make sure. And this time, instead of zeros, we have 300 and 600, so it keeps track of 600. We have all these scores, and the last score was 2,400, so it kept 2,400. That works. Let's go on to question 2. Question 2. The book class is used to store information about a book. A partial book can be defined here, and they give us a snippet of what a book is. You will write a class textbook, which is a subclass of book. So we're talking about inheritance here. This question 2 seems to be probably the easiest one. We're just going to inherit and create a textbook class. A textbook has an edition number, which is a positive integer used to identify different versions of the book. So we have an integer. The book info method will return the string. So in the superclass we have get book info. So this new get book info will return a string that also includes the addition as shown in the example below. So we're going to have to probably call this and add to it. The information about the book and price can be maintained in the book class. All right, so all this we're not going to double this up. Information about the addition is maintained in textbook. Okay, that's straightforward. Textbook class has an additional method can substitute for, which returns true if a textbook is a valuable substitute for another textbook and false otherwise. So how do we determine that? The current is a substitute if 2 textbook objects have the same title and if the addition of the current textbook is greater than or equal to the addition of the parameter. Okay, I think we have it. So here's sample code. And we notice that get book info will look like this. So it's basically the previous get book info plus we add the addition that we add the addition. So we'll need to add on to that, and then we have some sort of can substitute for. Let's create a new class, textbook, and we want to inherit off of the superclass of book. All right. So we create this new textbook class, which extends book. We're going to create a new constructor. Now this constructor, like we have right here, has 3 values. We are already calling the super book title and book price, but we also need to add an addition. So let's int addition. Okay, so we need to pass an addition. That means we need to store addition. So let's do a private addition, or private int addition. All right, and we'll want to store that here. So we'll say this dot addition equals addition. All right, so we've got a new addition, and we're going to store the addition. Now we're going to want to create a get addition, public int get addition. All right, and we're going to return addition. All right, let's pretty that up. All right, so we've got that. Now we want to override the get book information. So we don't necessarily need the for the exam purposes. We don't need that annotation, but we're going to want to get book info, and we want to add the addition onto this. So get book info already has, if I look at the get book, the book info already has title and price. So we need to add the addition. So we want to return what we have in the first one, but we also want to add dash as well as the addition itself. That should do it for us on that. So we storing an addition, we're getting an addition, we're getting the book info, and lastly, we're going to need to create a new function called can substitute for. And it's going to need to take in another textbook. So if I was to create a new function, so how do we, looking back at the instructions, how do we implement can substitute for? So we return true if two textbook objects have the same title, and if the addition is greater than or equal to the addition of the parameter. All right, so going back to the code, so we want to return if book.getTitle, so we want book.getTitle equals this.getTitle. Now you can probably you don't need this. You can just say getTitle because it implicitly knows that we're talking about this. But we also want to check if the addition is greater than or equal to. So let's say this addition is greater than or equal to the book's addition. Now we'll call get addition for this. Yeah, and to make it look cleaner, I'm going to put this down on a different line. We're comparing the title, if it equals, and if this addition is greater than or equal to the book addition. Okay, that should be it. Let's take a look at the runner and see. Or let me save this and close the other ones. Let's take a look at the runner and see if that works. So here in the runner, we've got the exact sample data that we saw in our PDF. This is the sample data here. Let's run it, clear out the last question, and see if this works. Okay, we have 3, biology 339.75-3, true, false, and false. And that matches our sample data. Let's move on to FRQ3. Okay, FRQ3, users of a website are asked to provide a review of the website at the end of each visit. Each review is represented by a review class, and it has a rating and a comment. The comment field in a review object ends with a period, an exclamation point, or a letter, or an empty string if the user didn't enter a comment. So we have just getters in the constructor. And now we have a review analysis class, which contains method used to analyze the reviews provided to the user. Okay, so we have an array of all views. We have a constructor we don't care about, and we have get average rating and collected comments. This is what we're going to be implementing. Part A, write a review analysis method, get average rating. So we're going to complete the get average rating, which will return the average rating, the arithmetic mean of all elements of all reviews. So for example, we have these reviews. We're going to return a double, which is an average. So we're going to average all these numbers up. So add them up and divide by the number. And that should be it. Let's hop into code. Let's close everything out and take a look at review analysis. All right, so we're going to want to implement this get average rating. Let's start off with setting an average. Let's say double average equals 0. And we're going to return the average. Now we're going to loop through this and calculate. We're going to loop through all of these and calculate the average. So this sounds like an extended for loop for review R in all reviews. We're going to want to sum this up. Average plus equals R dot get rating. All right, so we're putting it all into a double. Now we're going to want to divide by the length. So I'm just going to take the length of all reviews Now, just to make sure, I'm going to cast this to a double. So we're doing double math. Double on this side should return a double here. That concludes part 1. Let's take a look at part 2. This seems to be a little more involved. We're going to have to deal with characters. So we're going to collect the comments, which collects and formats only comments that can contain an exclamation point. So this is a key point right here. So we're only going to look at comments that have an exclamation point in them anywhere. The method returns an array list. An empty array list is returned if no comment in all reviews contains an exclamation point. So the string inserted in the array list begins the index review. Okay, so it looks like we found in this example, there's an exclamation point. So what we're going to collect is the index. So we found this comment at point 0. We're going to have 0 dash and then add it. An index is immediately followed by a hyphen. So the index, hyphen, and then a copy of the original comment. The string must end with a period or exclamation point. If the original does not end in either, a period is added. All right, so what does all that mean? Let's take a look. So this sample list returns this result. So we found an exclamation point at 0, so we're going to add in the array list the index 0 dash and the comment. Now the comment, like it says in this last bullet point, doesn't contain a period or an exclamation point, so we have to add on a period. Great. Looking at this one, there is no exclamation point, so we keep going. This one has an exclamation point, so we say index 2 dash great, and because it ends in an exclamation point, we don't do anything with it, we just leave it alone. This one has an exclamation point at index 3, and it ends in a period, so we don't do anything with that either, we leave it alone. Last thing is an empty string, and we don't do anything with that. All right, I think we have what we need. Let's take a look at the code. We're going to have an array list, so let's start off with creating the array list. Always start with your basics whenever you're doing this. What's a thing that needs to be returned? So I'll take a list of collect, and we'll initialize it to new array list. And we're going to return it, return collect. I would use an extended for loop, but we need the index. So I'm going to go with your traditional for loop for int I equals 0. I is less than all reviews length. So this is pretty standard stuff. I plus plus. Now we get into the meat of it. Let's create a hold string, and we'll add the index right off the bat. Whether it has an exclamation point in it or not, we don't care. We're just going to hold on to that. So we grab the comment. Now we want to check to see if that value, if hold, has an exclamation point. So how do we do that? We're going to use the index of function. If hold dot index of, and we care about the exclamation point character, is greater than or equal to 0. So if it's not -1, I always like to do greater than or equal to 0. We're going to want to grab the last character and see if it's an exclamation point or a period or not. So let's create another variable, string last, and we're going to set this to hold.substring. And where's our beginning index? We want hold.length -1. This should give us our last character in the string. Let's take a look and see if it's an exclamation point or a period. So if last.equals exclamation point. If it doesn't equal exclamation point, and not last equals period. So if the last character doesn't have an exclamation point or a period, we're going to want to add to that. So hold dot, we're going to add a period. Okay. Lastly, we're going to want to add this here. So still in, so we don't want to add it if it doesn't have an exclamation point. So we're going to, at this point in the if statement, we're going to say collect dot add hold. All right, that should do it. Let's give the runner a try and see what happens. All right, so we've simulated the example in the PDF. Let's run it and see what happens. Okay, so we found out that the average rating is 3.4 like we had predicted, and the 3 values are good, 0, good, thanks, and we added a period. 2, great, with an exclamation point when we didn't do anything, and 3, poor, exclamation point, bad. We don't do anything, we leave it as is. That works. Let's move on to FRQ4. I think they say the hardest for last, so let's go down to Question 4. The question involves a two-dimensional array of integers that represents a randomly generated data. A partial declaration of the data class is shown. So we have a two-dimensional array. We have a max number, which is not shown. We're going to write two methods to repopulate and count increasing calls. Part A. Write the repopulate method, which assigns a newly generated random value to each element of the grid. Okay, not bad. Each value is computed to meet all the following criteria, and all the valid values must have an equal chance of being generated. Each random number has to be between 1 and max, inclusive, so it's not 0 and it's going to have to include the max number, whatever that is. The value is divisible by 10, so between these two numbers, we're only going to include random numbers that are divisible by 10. And we also have to make sure that the value is not divisible by 100. These two things just throw it for a loop. Okay, let's close everything. And let's open up data. We're going to do this repopulate. This is difficult, so we'll start off by at least getting credit for looping through the grid. For int r equals 0, r is less than grid.length, r plus plus. That's simple. And we'll do the same thing for the columns. We'll loop through columns where columns is grid for that particular row length. Column plus plus. I've chosen to do it the inefficient way. And that means we'll keep doing random numbers until we find one that fits the criteria. Let's do a while loop. While not fit. We'll just create a Boolean here where Boolean not fit equals true. So while this doesn't fit, we're going to keep looping. And once we find a int hold equals 0. So at the end of this, when we finally find the random number, we're going to add it to that particular point in the grid. So that's grid r c equals hold. So we're going to continue to loop and find a random number that'll fit the criteria that we have in the spreadsheet in the list. So let's generate a number. Hold equals, we want an integer, and we're going to use math random. That generates a random double between 0 and 1. We want to multiply it times max. And now that we have that, we want to increase it by 1. So instead of 0 to the number before max, we want 0 to max. It's always going to be starting at 1. It's going to go right up to max. If we didn't put this, it would go from 0 to max minus 1. Now we're going to have to check to see if it fits the criteria in the FRQ. So let's set not fit equal to, we got to evaluate hold to see if it's divisible by 10 and not divisible by 100. So hold mod 10 equals 0. So it's divisible by 10, and hold mod 100 is not divisible by 0. Okay, so we've taken the two criteria, and we want to continue looping if it doesn't. So we've taken this criteria and surrounded it with a not. So we want to keep looping while this doesn't match that criteria. Once it does match the criteria, it'll exit out of the while loop and set it to grid. And that's it for part A. Let's go on to part B. We're writing the count increasing calls method, which will return the number of columns in a grid that are in increasing order. Here's the following example. The return value for the following contents of grid is 1. Since the first column, so this first column is in increasing order, so 10, 20, 30, that's increasing, but 50, 40, 50 is not increasing, and 40, 20, 30 is not increasing. So we've counted up how many columns are increasing, and this column, only the first column is increasing. In the second example, it's going to return 2 because 10 to 220 is increasing, 540 to 450 is not, 440 to 440 is increasing. We're going to term it as increasing because it's not going down. So we're going to add this to the list, and lastly, we're not going to include this because it goes down. That kind of sums it up. Let's go back to code. We start off, we're going to need a count. So let's create a variable, int count equals 0, and we're going to want to return count at the end of this. This is tricky because usually we go from rows to columns, so we're going to have to kind of go backwards. Let's do a for loop for int c equals 0. C is less than grid, we're going to go to the first row and get the count of how many columns we got, which is length, then C++. Now that we're looping through each column, we want to count the rows. We're going to create a variable called hold, int hold equals 0. And we also want to have a Boolean that tells us if the changes between each row increases. Equals true. So right now we're going to assume that it's increasing, and we're going to loop through each row for int row equals 0. Row is less than grid.length r++. So we're kind of going in column row order instead of row column that we're used to, because we want to count up columns. I set it to 0, but we don't know if these are negative values. Let's set it to the first value in the column. So how do we do that? We go to the first row, and we pull back that column. All right, we have a good handle on this particular hold. Now we're going to check to see if the grid at that particular row, grid, row, column, is less than hold. If it is, if this particular point is decreasing, now it could be the same, but if it ever decreases, we no longer want to count it as an increasing row. So we're going to set increasing equal to false. Okay, so otherwise it'll be the same or increasing. So we're looping through each row in that column, checking it. And now we want to increment the hold. We want to set hold equal to that point for the next iteration through the loop. Once we've gone through the entire for loop, we're going to check if that whole column is increasing, we'll add to the count. And that's it. Let's go to the runner and see if this works. So we're going to run repopulate twice to see if it generates random numbers between 1 and max. And just for giggles, we put the max at 1,000, so hopefully that'll give us a good sample data. And then we run the count increasing calls for the first sample and for the second sample. Okay, so we ran repopulate twice, and it gave us random numbers between 1 and max that are multiples of 10, but not multiples of 100, because you notice there's no number that ends with 2 zeros. And the same thing, but they all end with at least 1 zero, meaning that they're divisible by 10. So that works. And if we look at the count increasing columns, we notice that grid returns 1 because this column is increasing, and this one returns 2 because this column's increasing and this column's increasing. This concludes our review. Thanks for joining us.